3.2 Electrode Potential. It is the potential difference set up between metal and its ions in the solution, or it is the tendency of an electrode to lose or gain electrons. The tendency to lose electrons is called oxidation potential, whereas tendency to gain electrons is called reduction potential. Okay, the standard potential E naught, the condition would be 1 molar concentration and 1 atmospheric pressure and 25 degrees centigrade, that is 298 Kelvin. These are called standard electrode potential. Suppose if we take half cell like this one side half cell, that is zinc rod dipped into its solution like zinc sulfate. Okay, so the zinc sulfate here, the rod has tendency to lose electrons. So it may be lose electrons means all the negative charges are present at that rod. Okay, the positive charges are present accumulated in the solutions. Okay, so here the rod would be negative charge and in the solutions it would become a positive charge. Okay, so here the difference between these two charges, that is metal rod and the metal rod present in the solutions, the charge difference, it occur the potential difference of the solutions. Okay, that is called oxidation. Where it is occurred oxidation, anodic cell. Anodic cell, it undergoes oxidation reactions. First of all, the zinc in solid, so it gets oxidized, dissolved, it gets oxidized zinc 2 plus and to lose 2 electrons. That electrons are present here. Okay, so the charge between this metal and this, the metal present in the solutions, it occurs the potential difference, that is called oxidation potential. At the same time, take another one half cell, that is the tendency to, here you see the tendency to gain electrons. So where it's happened for reductions. So here the copper rod, it gain the electrons, gain, so it occurs the positive charge. This positive charge to attract the negative charge from the solutions like copper sulfate. So the charge between these two rod and the solutions, it may occur the potential difference of this cell. Okay, so the total potential difference between these two half cells, okay, that is volt. Okay, that is, it creates the electric energy, that is volt. Okay, so that is oxidation potential or reduction potential. Here reduction means the copper 2 plus gain the electrons and it gets reduced to copper. Okay, the total the difference between these two half cells are called E naught cell, that is cell potential. Cell potential equal to E oxidation plus E reduction. So that is cathode. Okay, so the E naught cell is nothing but electromotive force. Electromotive force na இங்க எவ்வளோ எலக்ட்ரான்ஸ் வந்து அந்த ஃபோர்ஸ் அட்ராக்ஷன், that is called electromotive force. Okay, to reach this another half cell, that is electromotive force. Okay, children, the potential of each half cell cannot be measured individually. Okay, because the difference between these two half cells are E naught cell. Okay, we cannot measure the single electrode potential for each. So we can introduce reference electrode, that we have to continue next part. Next topic is measurement of electrode potential. Okay, so electrode potential, we cannot measure individual standard electrode potential for the electrode. Okay, so we have to prefer standard hydrogen electrode. So standard hydrogen electrode is nothing but She. Okay, that is what the construction of She is. Here take this container, the inverted glass tube is present. That inverted glass tube interior one platinum foil coated with carbon black. Okay, this platinum foil, this platinum wire dipped in 1 molar HCl. Okay, and also this the glass tube, it contains one outlet, that is the passing of hydrogen gas at 1 bar pressure. Okay, this standard hydrogen electrode maybe act as an anode or maybe act as a cathode, because of it is a inert kind of electrode. Inert means nothing to do. Okay, no reactions takes place. Okay, so suppose it act as an anode. Anode means which reactions takes place? Oxidation reactions takes place. So the presence of H2 gas dissolve this HCl and it gets oxidized to lose 2 electrons. Okay, so suppose it may act as a cathode, reduction reactions takes place. So the presence of H plus ions in the solutions gain 2 electrons and it reduced to H2 gas. Okay, so totally the standard hydrogen electrode potential value would be 0.00. So that only we have to take this is a reference electrode. Okay, so suppose we are going to calculate a single electrode potential for the half cell reactions. One side the standard electrode potential is there, another one side in which cell we are which electrode we are going to calculate the electrode potential, that electrode is present. So I will show you how the apparatus setup. See here, measurement of standard potential of zinc in zinc 2 plus electrode using standard hydrogen electrode as the reference electrode. Okay, so there are two half cells. For one side, this is left hand side, anodic reactions takes place. This is right hand side, cathodic reactions takes place. Okay, so that is reduction reactions takes place. Okay, for reduction reactions we have to take she means standard hydrogen electrode. Okay, for right hand side zinc rod dipped into their into their solutions like zinc sulfate. Okay, so we have to calculate the standard electrode potential for zinc. Okay, first illustration 1, zinc in zinc sulfate, zinc in zinc 2 plus salt bridge. This is she means that is standard hydrogen electrode. Okay, see here its E cell value in the electrode potential value is given 0.76. Find EMF of Zn Zn2 plus, that is oxidation reactions. Anode use ABC rule. Okay, A for left hand side, that is anode. Anode it undergoes oxidation reactions, and salt bridge the right hand side always it undergoes cathode. Cathode for reduction reactions takes place. Okay, here the cathode she is present. She means reference electrode, standard hydrogen electrode is present. Its volt, the volt is 0 volt. Okay, so the known volt is 0. We have to measure the electrode potential for another half cell. Okay, so E naught cell value is how much given? 0.76 voltage equal to E oxidations we have to measure. Okay, E oxidation we have to measure plus E reduction is 0 volt. So E oxidation equal to E oxidation equal to 0.76 volt. Okay, this is oxidation potential. Okay, suppose ask reduction potential means the sign easily the reverse form takes place. So the sign alone you have to change. E reduction equal to minus 0.76 volt. That's all. Illustration 2. The EMF of the following cell at 25 degrees centigrade is equal to 0.3 volt. Okay, this is E naught value. Calculate the reduction potential of copper electrode. Okay, so for here also use ABC trick. For left hand side A anode, for right hand side for salt bridge right hand side that is C cathode. Okay, here the reference electrode is present anode. Okay, so it undergoes oxidation reactions and also the known voltage is 0. Okay, that's all. So E naught E cell value is given 0.34 volt. Okay, so here E cell equal to E oxidation plus E reduction. Okay. Then E cell value is what? 0.34 volt equal to oxidation, the reference electrode, its known potential value is 0. So we have to put 0 plus E reductions we are going to measure now. So E reduction. So E reduction equal to, the value is equal to 0.34. Okay. So the copper, the electrode reduction potential of copper electrode is 0.34 volt. Okay. Illustration 3. Using the calculated EMF value of zinc and copper electrode, calculate the EMF of the following cell. Okay. So for here also use ABC rule. A for anode, it undergoes oxidation. This is salt bridge right hand side, this undergoes cathode reduction reactions. Okay, already we knew that the oxidation potential for zinc is 0.76 voltage and the reduction potential for copper, the value is 0.34 volt. Just we have to the data we have to put. Okay, so E naught cell value, E naught cell equal to E oxidation plus E reduction. So oxidation 0.76 plus E reduction 0.34. Okay, E naught, the cell potential value equal to 1.1 volt. Okay, so students, I hope you understood. The redox reaction la normally வந்து both oxidation reduction நடக்கிறதுனால we cannot measure the standard electrode potential. Okay, so we have to take standard hydrogen electrode for half cell reactions. Okay, so இப்போ ரெண்டு half cell இருக்கிற இடத்துல ஒரு சைடு left hand side ஓ right hand side ஓ நம்ம ஸ்டாண்டர்ட் ஹைட்ரஜன் எலக்ட்ரோடை வச்சுக்கிட்டோம் அப்படின்னோன்னா அதோட நோன் வேல்யூ நமக்கு தெரியும், 0 வோல்டேஜ்னு தெரியும். அதனால் அன்னோன் எலக்ட்ரோடு பொட்டன்ஷியல் வேல்யூ ஃபார் அனதர் ஹாஃப் செல்லை நம்ம ஈஸியாக என்ன செஞ்சிடலாம், கால்குலேட் பண்ணலாம். அதுதான் அதுக்கு வந்து என்னென்னா, எப்போவுமே ஆனோடுனா ஆக்சிடேஷன் ரியாக்ஷன்ஸ் நடக்கும், கேத்தோடுனா ரிடக்ஷன் ரியாக்ஷன் நடக்கும். அப்போ ரெண்டு ஹாஃப் செல்லில் வேர் த ஸ்டாண்டர்ட் ஹைட்ரஜன் எலக்ட்ரோட் இஸ் ப்ரெசன்ட், வெதர் இட் மே பி ஆனோடு சைடு ஆர் இட் மே பி கேத்தோடு சைடு. கேத்தோட் சைடுனா அந்த வேல்யூ எங்கே இருந்தாலும், ஆனோடாக இருந்தாலும் கேத்தோடாக இருந்தாலும் அதோட வேல்யூ 0 தான். ஸோ இந்த பொட்டென்ஷியல், இந்த ஈநாட் செல் வேல்யூ எல்லாமே மேபி உனக்கு வந்து என்னது, த கிவன் சம்ஸ் ஆல்சோ இட் இஸ் கிவன். ஓகே, ஸோ டோன்ட் பி ஒரிட், ஈஸி. ஓகே.